Thank you all for coming. This is going to be the Badge Life badge panel for DEFCON 25. In front of you, we have a bunch of badge makers, independent badge makers, unofficial badge makers. All of us are friends from Slack. We are on Slack for sharing our ideas, sort of humble bragging, and all of the fun things that we like to do. I guess we'll just get in complaining and lots of complaining. So I guess we'll move forward, and we'll start with the first badge, right? So you guys want a mic? Yeah. Why don't you come over and grab the mic? Yeah. There you go, Nick. There you go.
Hey. Okay, here we go. Oh. Hey, I'm John, a.k.a. Netic. We created the Ides of DEFCON badge, which has been surprisingly popular. That's this guy. See, I just rebooted it. This is the problem with your own hardware. It's so fragile. All you need to do is short out the right pins, and it automatically reboots. This is a feature, not a bug. We produced about 225 of these. We had about 5 people on our team. We had a hardware person, software person. Bill Paul is standing next to me. Bill was a low-level firmware engineer. He worked on all of our drivers, radio drivers. The concept of this was we were coming to DEFCON 25, and we wanted to do something great for the 25th year of DEFCON. I personally have been coming to DEFCON for about 20 years. And we said, oh, Caesar's Palace, we have to do Rome. We have to bring back the Ninja Network. So like DC-18, Ninja Networks did a fighting game, and we sort of extended that and made it more modern. I think it was next slide. So the device consists of an ARM Cortex M0 processor. The KW01 has a 915 megahertz AES 128-bit encrypted radio that runs in the ISM band. There's a chip antenna on board because doing your own RF design really sucks. And you know the effective range of this device is probably 30 to 50 feet. It's not very good. I don't really know RF, but we made it go. We have a 12-bit DAC, so we can play audio. We have amplifier, speaker, 4 gig SD card, 320 by 240 TFT touchscreen, and there's a joypad plus an FTDI chip. So if you plug in a USB cable, you automatically get a console. And then we have 12 of the WS2812 RGB LEDs. Boo! The RGB, the WS2812 is on almost every person's badge here. It is an epic piece of shit. Do not use it. It does not survive reflow. You should never solder it any other way than by hand, preferably with labor that is not yours. 1200 milliamp hour battery in the back because, oh my God, every time you go to DEF CON, your battery dies. The nice thing about this is you can also plug in the USB cable and charge. Are you attacking me?
No.
You're attacking me.
No, you.
Oh, someone else is. Anyway, you can plug in a standard USB cable and get a console and charge the badge. Next slide. Boop. So what did we learn? Try to use pre-made systems on a chip with RF built in. RF design is difficult. The entire design that we had was plagued by a really shitty footprint we have for the KW01. We had so much solder float. I have spent the last 3 days in a hotel room with a microscope looking through it and resoldering and reflowing badges, which I did starting at 8:30 this morning, and I haven't even had lunch yet. My entire lunch has consisted of 1 beer because I have been so busy fixing badges. But we did very well. At the end, we ended up with a 14% failure rate, which I think is really awesome. Do proper design for manufacturing. So if you're making badges, put a test system in the badge. Make sure you test things. So at least on our badge, if you eject the SD card somewhere, and then you reboot, then we blink the lights RGB, and that tells us the lights are good. And if you hold down all the buttons, then we will light the lights white that says all your buttons are working. Exterminate. That's Bill's phone. It's awesome. And then also be conscious of design the user. We tried to make a really nice package and make it look great for people. Next slide. I think that should be it. Oh, and just some photos. We used KiCad. This is the evolution of the badge real quick. I don't want to take up all the time. But we started on a breadboard. We went from breadboard to development board to prototype to this massive, ugly Flavor Flav prototype. And then we went to, in April, we had our first real board. And then we finally produced in May 2017 the final. Next one. Yay! And thank you. I hope you have fun with it. And Car Hacking Village team.
Yeah, but can you hack it? Can you hack it?
Yes, it's completely hackable. There's a secret puzzle, and I will give you a clue to start the puzzle underneath the screen. Take the screen off. There's a URL or something you might want to do something with.
Okay.
You'll figure it out.
All right, cool. Nathan? All right, hello everybody. This is Nathan Hoke, and I'm Robert Lieli. Well, when I say we, I came up with an initial design, and then I let Nathan do everything else. So I'm going to hand the mic over to him, and he's going to tiredly tell you everything that we did.
Yeah. I've been up for quite a while. I understand the stories about using a microscope. I was doing that in the back of the car from the drive between Fort Wayne.
Let's not get ahead of ourselves.
Okay, let's not get ahead of ourselves. Okay.
All right, ready?
So basically, you know, we wanted to come up with something a little bit more unique than just a standard badge. So Robert and I came up with this idea of a belt buckle because we have a lot of truck stuff going on in the village. So Robert came up with this badge wearing modes state chart. So basically, you know, you have the various modes that you can wear this thing in. Belt mode, badge mode, right?
You can wear it on your armband?
Yep, headband, ankle band, thigh band, and then you decide, right? But one thing that I always try to do with the Car Hacking Village badge is I've always wanted it to be more than a badge. You know, being an engineer myself and working a lot with automotive stuff, I like to make a badge that, you know, first and foremost is a badge, but after DEFCON's over, you know, somebody who, you know, works on the kind of stuff that we do could possibly use it to, you know, every day as a development tool. So I always try to put in a lot of extras into it that people can use. So this year, you know, depending upon which badge you ordered, whether it was a pre-order badge or the one, you know, you got here, you got a lot of different automotive interfaces, some of the newer ones too. So, you know, CAN-FD and Automotive Ethernet, etc. You know, big thanks to NXP, sponsor, and Rapid7 for helping out on this, because, you know, in order to bring a lot of these more advanced automotive interfaces into a badge that, you know, costs $50, you know, can be quite challenging. So thank you very much. So, you know, a lot of you are probably familiar with the process. I mean, you know, we paste boards, we pick and place, we reflow, and then we work on them in the back of a rental car between Fort Wayne, Indiana and Las Vegas, because when you try to ship LiPo batteries, no matter how much process you go through, I had 2 people at FedEx tell me that I had everything in place. The driver shows up a week and a half before DEFCON. He's like, I can't take these. I'm like, well, what are you talking about? I talked to 2 different people. He goes, well, you don't have DOT form this, and you don't have this. So I'm actually kind of glad that I made the decision again this year to drive them, because
Last year we had to do this.
Last year I had to do this as well, but that was my fault because I dropped the ball. I thought I could just like throw them at FedEx and ship them. Well, that was pretty naive. So this year I really tried, but I'm glad that I didn't, because FedEx called me like 2 days later and said, hey, you missed your pickup, right? You didn't give anything. So they were telling me the horror stories of what happens with hazmat stuff. You know, it'll get accepted. It'll go from Fort Wayne to Kansas City, and then some curmudgeon who's in, you know, whatever department there at that FedEx facility will say, sorry, we can't ship this, which, you know, DEFCON is not going to reschedule for our badges, right? So got to do it.
Cool.
So,
but can you hack it?
Yes, you can. So last year, you know, the last year and the year before, it was kind of a closed system that you could script using Pawn to do a lot of stuff, which was cool. But this year I wanted to kind of open it up more. So, you know, on our website, I'm just, you know, all the schematics, all the software, everything. So somebody could actually use this in the way that I, you know, was explaining before. Basically, you know, use it to do stuff after DEFCON, right?
Thanks. Yay! Car Hacking Village badge. Thank you. Who's next? All right, DC 801. Yeah, here you go. All right.
You go, Sam. Come on, sir. Hi, I am Rushan. I'm the... Is this on? Okay. I need a whole tire. So I'm the parts junkie artwork guru. I did majority of the design of the DC 801 party badge and that layout and how to carry it. And then Michael Peterson, Celerity, he helped do the layout and Eagle of the badge. He's not able to attend DEFCON here. And then we got Hamster here, which is our master programming guru. Code Monkey. And then we have Nemus, which is our wizard that helped organize the back-end stuff for our badge. Our badge is a homage to Helga, a special, which is a sheep that deals with our DC-801 space that if you come to our party, you'll learn more about. Special DEFCON 25 badge. Prototypes are all in yellow to deal with Golden Fleece and get in with the mythology. They all have Hermes helmets, and the final badges are in white. They grant VIP access to our parties on Saturday night here at DEFCON. We pre-sell them early, around May or June of the year. 801 Labs is a hackerspace, so all the proceeds that we get from the badges goes back to our hackerspace in Utah to help make that better for everyone else. And there's a few other hidden meanings within the badge. If you look at it, different labels on it, and there's some hidden buttons. Okay. Next. Hey, basic specs, we're using a Regato BMD 300, which you notice there's a few other independent badges using that. It uses a Nordic NRF 52832 and a ARM Cortex M4F processor. It has about 32 GPIOs, 512 kilobytes of flash memory, and 64 kilobytes of RAM. We run fully off of the onboard chip. And then we have 2 RGB eyes, which on the final badges are rotated 180 degrees. So if you want full green capability, you need to learn to desolder and resolder on your RGB. Nothing goes perfect.
Enjoy the 0102 resistors that are right next to the eyes.
Yes, we use small things because we fully kit out our badge, and it's fabbed for us because we want to enjoy DEF CON a little bit more and not spend time doing badges all the time. So it's a lot of fun. Programming is one of our longer pulls in our development. It has a speaker, it has 6 red on the wings, and then it also has a red charging LED, and then it has 7 yellow ones for the helmet, so you have a golden helmet with red wings. To go with it, it has 2 capacitive buttons that you need to figure out where they are. There is a test mode functionality code-wise that you can get into that you can play around with to figure out where the buttons are. So when we release our source code and everything at the end, you guys can play and program and have fun with the sheep. What else is there? We're right in front of some of the words. Yeah. It has an LCD screen, has selected pinouts right underneath the LCD screen, right above the buttons. JTAG interface, micro USBs only for charging. You cannot program through it. And that's basic there. Software development is Eclipse, GNU, ARM, GCC. You need to set your J-Link to really program it. We do put the programmer port on the badge. So you get the education one, 60, 70 bucks, program all ARM chips. Pretty nice. Bomb girders all after, look at the DC-801 GitHub after the con, and we'll have everything released, full files, and everything. Okay, some precursor things. We started with the basic design of the sheep, and then started doing layout in Eagle, and make sure the parts line up right, get our silk screen the right size, everything else, figure out a way of carrying it. We didn't want to do normal lanyards, so we decided to do 6 inches of Velcro, and then give you an awesome S-beaner that's also a bottle opener. Figured it's very useful at DEF CON to have a bottle opener and have a badge that you can print anywhere. So you don't have to wear it around your neck. Okay, go next. Some tips. So there's always a contest for our DC-801 badge. During LineCon, we usually have some people throwing out coins or other things that some of you may have picked up that has a male sheep on a ram, and that goes for a contest that you can end up winning a DC-801 badge. And we also have another contest for whoever makes the best can crusher to go back to our hackerspace for our recycling efforts. We'll also win a badge. So pay attention how the badge changes. You kind of notice our screens rotating because some of the other badges are also BLE enabled. So we do have some hellos to other badges. Another key thing, follow the badge makers on Twitter if you want to learn more about badges and when things get released and whatnot. And Anything else?
Yeah, so we were really fortunate to have our badge maker Slack this year, and we were able to develop something of a common Bluetooth protocol so that the different badge groups can identify each other and somewhat talk to each other depending on functionality. And the final thing that we did on these guys is we're running a game of contagion. So we'll see, you get to enter what we're calling an offensive vector into your badge. So we'll see by the end of a weekend who comes out on top as which team infects the most badges. So watch for that.
Oh, yeah, and that will be at our party. So come to our party, and we'll have a blee sniffer and everything else and projector and see all the fun blee badges at our party. Hey, all right. Oh, they aren't.
They're not here right now. I guess I'll just do this real quick. No, I'm kidding. So I guess we'll skip over them. They might come later. So we'll come back. We'll come back to them. Yeah, me too. Maybe they're too busy doing flash sales for now. So okay, here we are.
Hi, I'm Borgle on the internet. I'm a random asshole who decided I was going to make a badge for DEF CON because I came to DEF CON for quite a while and planned every single year to build one, and then finally got off my ass and actually did it. So it is a dragonfly. If you've read the book, The Diamond Age by Neil Stephenson, it's a book I quite enjoy. There's a sequence in which a character goes to a party and everyone is wearing these funny cloisonne dragonfly pins, and over the course of the party they notice they kind of synchronize, and then in the context of the book there's nanites and other crazy shit. There's no nanites. There's no nanites in the badge, just to be clear. The team is me. I did the things. The theme of this was, so last year I kind of tried to build a few and mostly failed, but last year the theme was learn about electronics. This year the theme was learn about building more than one of something, which means, God, that's so hard. So that means focus on reliability and reduce risk. So that means reduce financial risk, and there's a bunch of money stuff in here. And it also means reduce risk of failure, increase yield, things like that. Beep. Okay. So I have no features besides exactly what it says on the tin. It has no puzzle. There is, like, SWD is available, so if you want to reprogram it, you can do that. You can plug into the UART. There's no puzzle there either. It does exactly what it says on the tin. So if you're alone, it does random RGB fades, and it beacons periodically in infrared. And if you are near other people, it will use the beacons to synchronize a clock, and then they'll kind of all traverse the color space together. And then as you move away from each other, they'll spin off randomly into RGB fading again. Last year the code didn't work at all. This year the code actually works, which is cool. It also has a button, which you can use as a TV mute toggle button. And it also kind of juices other people's dragonflies. So that's been neat. There's no other features. My features are low cost. So I'm using almost the shittiest STM32F0 because it turns out they're really inexpensive from China. I'm using APA 102s, which are sort of like they're a 6-pin. They're almost like the NeoPixel WS28 whatevers. They don't melt. Well, they don't melt sometimes. They're impossible to hand rework. I successfully can do them in my reflow oven most of the time. It has an infrared LEDs and a receiver and a battery. You can't charge it. That's cost. It doesn't have a switch. That's cost. In assembly time. Can you go to the next one? We'll see if... Okay, so again, reduce risk. So lots of iterations. I have a little CNC... I have all these with me if anyone wants to see them. I have a little CNC mill, which is really cool for cutting circuit boards. So I cut the first version of the board, which is broken button, fucked up infrared receiver, ripped a pad off for the IR LED, but this was enough to prove that it would work, which meant that when I made the next one, I was less likely to be wasting money. This one was also wrong. I also discovered that I was going to switch CPUs, and that required a little bit of rework. And you'll notice on the final one, I eventually ripped some buttons off because that reduces cost and reduces assembly time and reduces failures. I made it a cool shape because I figured I'd end up with a bunch of them. I'll talk about these LEDs in a minute. I did another iteration, which is functionally equivalent to the final one, and then a final iteration to make sure the size and the shape and everything was right, and then the real final one that came after that had the real silk art and everything, courtesy of my mom. She did a great job. I really appreciate it. Can you... Shout out to moms. Awesome. Okay, so these were all hand assembled. So the cost to me to build one is about $7. The cost, including all my rounds of prototypes and burned parts and everything, comes out to about $9. So that's thoroughly in the like beer money sort of zone, which was exactly where I wanted to be. I had no idea what the market would be like. So the plan was to reduce my personal financial risk because there's no sponsorships, and if I ended up selling none of them, I didn't want to be in a hole that was too deep. Hand assembly means optimized for things that you will probably succeed at hand assembling. If you look at a crypto privacy badge, they use these incredible 2mm square versions of the same LED I use. I was going to use those, but those are basically impossible for me to hand assemble, so I didn't use them. Let's see, I think there are other examples. I have a couple workarounds. So these LEDs fail during reflow pretty frequently, and if you look at the back, there are these little solderable jumpers you can use to cut them out of the chain in case they fail, so I don't have to fix them. There's also an extra pair of holes at the top. In case I couldn't get the IR LEDs I was expecting, I could just swap in a through-hole one. So there are a couple things like that. If you're building one yourself, cost compare with China. China will save you unbelievable money on certain things. So I switched CPUs because it turned out the CPU I was using I couldn't get from China, but boy, I could get this slightly worse CPU for almost nothing. And I got like a CPU tray in saran wrap in a padded envelope from China. It was great. So at some point it was like, okay, cost compare. Well, if I switch to this part, it'll be cheaper or easier. So that's totally worth doing. Have test firmware. Other Netiq had test firmware. So there's a version. The first thing I flash it with lights the LEDs in response to the button and the IR and stuff. Super helpful for fast testing. Surface mount parts are scary, but you kind of, if you want to assemble things like in a manufacturing line, it's easiest to do surface mount. If you do surface mount, get a paste stencil. It's Google around or ask me or something. They're very easy to use. I built this little programming fixture using these little spring-loaded pins out of another Dragonfly, so I can just press it on top and push program, and it programs it, which means I don't need to solder headers, which saves cost and time, like everything else. It also makes it really easy to reflash them, which is useful. Let's see. It's a marathon, not a sprint. I worked on this for like 9 months. I would guess that most of these other people worked on them for similar or longer periods of time. It's just a little bit every day, even when you really don't want to. And then at the very end, it's a sprint after the marathon, which sucks, but that's badge life. Sorry. Let's see. Yeah, strip unneeded stuff, pull off buttons I didn't need, things like that. I totally over-optimized my like cool animation framework, which is great now, but it made it basically impossible to debug, which was stupid. I shouldn't have done that. Don't optimize until you need to optimize, because you'll be wasting time. I think that's pretty much it. Cool. All right, cool.
Thank you very much. All right, let's do crypto and privacy, Carl.
All right, I'm Carl Kosher from the Crypto and Privacy Village. Hey, Justin, do you want to come up? Sure, all right. Yay. All right, so we did the Crypto and Privacy Village badge. I focused on the hardware development and the low-level firmware. As I'll talk about later, there's an 8-bit microcontroller and an ESP32, and so the low-level stuff on both of those I did. Whitney Merrill, another co-organizer of the Crypto and Privacy Village, did the badge art. She also made these PCB keys, also in KiCad, also produced at the same board house. They're pretty sweet and part of a puzzle, and developed some of the puzzles that are on the badge. And then Justin did Python development and wrangled China a lot. Boop.
Where's Slackbot when you do?
Oh yeah. So specs of our badge. I like to say that we have a quad core badge. So the ESP32 module actually has 3 cores on it. There's 2 32-bit Extensa RISC CPUs running at up to 240 megahertz. There's one ultra-low power core, which uses some custom instruction set, basically to like do GPIO and other low power things when so the rest of the CPUs can sleep. It supports Wi-Fi, Bluetooth low energy in there. It has a ton of peripherals, only some of which that we use. Has about half a mega of SRAM, although once you add in like Wi-Fi and Bluetooth and all that other, and MicroPython, which I'll talk about in a minute, you start getting crunch for space. The modules, We have an antenna built into them, and they have a flash chip on them, so we have 4 megs of flash. There's an 8-bit microcontroller that we use for power management and to talk to the LEDs and the rotary encoder. It also does USB to serial, and it's from Silicon Labs, and it's actually cheaper than the USB to serial dedicated chip that Silicon Labs sells, which is way cheaper than the FTDI chip that everyone uses. So it's a pretty nice piece of hardware, despite it being based on an 8051, and programming 8051 code is a nightmare because there's like 5 different address spaces, and it's a mess. We have headphone and microphone amps on here. We were hoping that the ESP32 SDK would support audio in. It doesn't yet. Technically, the ESP32 is still in beta, so they're still developing the SDK for it. So we made a gamble there, and we kind of lost on that, but oh well. Has an accelerometer on it. We don't use it. We were going to use it for other things that we'll probably do next year. Same with the crypto accelerator chip. Has a rotary encoder, and of course these awesome tiny LEDs that you absolutely cannot hand solder. You want a stencil for that in hot air. Beep. All right, so our process. So I actually forgot a lot of this, so I went back on GitHub and to look at actually what we did. So our first commit was in 2016, where we committed a rough outline of the badge design. And then through, the Christmas season and into the new year, we created the schematic. Next few months, we did the initial PCB layout, made the first prototype PCBs, had them shipped. In April, I started writing firmware to test all of the parts, assembled these by hand. Unfortunately, I got some of the footprints wrong, especially for like the LEDs, so I couldn't test that. So I started design of the second prototype PCBs, which were mostly the same, just with some footprint fixes. Then we got that back in May. We did more testing and tweaking of that. In June, we finalized our hardware design and kicked that off to PCBWay, who started the production process. So to do that, to actually assemble these things, they need like a very precise BOM or bill of materials. They need assembly and testing instructions. So we have to say, this LED is oriented this way, this chip is oriented this way, and show where all the orientation markers, and being very precise about everything so you don't end up with issues with rotated parts and stuff like that. So that took a while to actually develop. Same with the test firmware. So we had them flash some test firmware on there. Turns out the USB to UART firmware that we have on the EFM8 doesn't support anything. It supports OS X, Linux, and Windows 10. If you're on a version of Windows below that, you have to like install a custom driver. And so they were running Windows 7, so wrote a different version of the firmware that pretends to be that Silicon Labs part. And they just give you firmware for that, but it was wonky in other ways. So back like a week or two ago, I finally got MicroPython building on this. And then just, huh? Yes. So Justin starts, right about then. July 22nd, we got a UI framework up and running in Python. The nice thing about Python is it lets you be very productive in getting pretty fancy user interfaces and other things going. We wrote these bindings, so they show up as Python modules that you can make like a method call to, and it calls some underlying C code, which messes with the hardware. And so we were working on that, making some pretty good progress on that. Past week, furiously doing final assembly and firmware development. Today, as of 3 a.m., we started flashing the badges with the final firmware. And today at 10 a.m., we started selling the badges. Boop. So, yeah. So this was yesterday. This is my room at Caesars. So, you know, the beds are unusable, and we have boxes everywhere. And, yeah, so we were... so this rotary encoder is the only through-hole part, and that's where the battery goes. And through-hole parts and LiPo batteries don't really mix, so we had to, like... get some flush cutters and like make them nice and smooth. Then we put some double-sided foam tape on there, and it works rather well. But you have to cut off like 3,500 different connections in total. And so, you know, there's metal everywhere in my room now. Boop. This is sort of the aftermath of the initial assembly process as of last night. So this was right before we went in, well, it was actually several hours before we flashed the firmware. But basically, you know, this is badge life. Boop. So some tips. So 2 categories of tips. One about the badge that we made, and one about, you know, making your own badges. For the Crypto and Privacy Village badge, it's actually fully reflashable over USB. You don't need any custom tools to flash it. If you hold down the rotary encoder while you plug it in, it will come up as a HID device, which you can reflash the 8-bit microcontroller with some of the Silicon Labs tools. And then once that's up, then you can reflash the ESP32 with the standard ESP32 development toolkit. If you don't want to deal with that, there's MicroPython running on it. If you plug into it, you'll get a serial port. You get basically an interpreter interface, and you can start playing around with the badges directly from over USB like that. There's no puzzles in the firmware. If the firmware is acting strange, it's a bug. It's not a it's not a hint. We've had many questions like, oh, well, why does it do that? I'm like, no, it's not part of a puzzle. There are many things that we wanted to do in this badge that we just didn't have time for. As you might have noticed, there's a lot of hardware on there that we don't have software support for. So we might reuse a large part of at least the electrical design on this and do something interesting in the future. For, you know, making your own badges, start earlier than you were planning. We thought we did. It wasn't early enough. A lot of making the schematic was just, you know, picking out interesting parts and looking at the data sheets. And the data sheets will typically have like a typical application or example circuit, and you can mostly follow those and just mash them up together, and it will mostly work. Yep.
Yeah. So be very aware of every part on your bill of materials. Like, some parts you think there would be enough for, and you go to order them, and there are not 500 in the world. You cannot buy them without an 11-week lead time. That is not going to make it work in June.
Oh yeah. By the way, so we got a recommendation for a voltage regulator from Unofficial, and it was a great power regulator, and so we put it on our first prototype, and then we go to actually build them, and it turns out Unofficial bought out the entire supply of them. So it was either delay the badge by 12 weeks or substitute a different part. So we just substituted a different part, which required another prototype to ensure that we weren't building 500 bricks. And so that added some delay. We have these badge life shirts run DRC. DRC stands for Design Rule Check. Basically, it is a bunch of schematic and PCB tools will check for things like shorts, things that aren't connected, whether you have traces that are too close to each other. And so this just ensures that it can be manufactured and it matches the schematics. And there's also ERC for checking that the schematics are sane. I really like this book, The Hardware Hacker by Bunny. There's a chapter about outsourcing stuff to China and how to make bombs that China will build precisely. Basically, it's like you have to be very precise about what you want. You can't just say, "Oh, I want a 1 microfarad or 1 microfarad capacitor." You have to say 1 microfarad 0603 surface mount plus or minus 10% NPO COG. You have to specify like the precise type of capacitor you want. But the one advantage of outsourcing is you can get parts a lot cheaper than you can get from domestic sources. There's some pitfalls in getting stuff from overseas, but it definitely dropped our costs by probably 3x, I would estimate. Boop, boop. Oh, I think we're out of slides.
Yeah, well, we were
but
and didn't submit any. You're missing one tip, by the way.
What's the tip?
You know how to ship lipos.
What's your tip?
The tip was ask Crux. So Crux actually ordered. So one thing that was new for this year is a bunch of us are in a small Slack where we can talk about making a common Bluetooth protocol and doing group buys of things. And one of the things that we did a group buy for was LiPo batteries because they are an absolute nightmare to get shipped here. So we organized it with people at SynShop and DC Darknet Project, and basically they ordered something like 1,500 LiPo batteries directly to Vegas. And so, like on Wednesday night, we just get a text being like, "Hey, I got the goods. Come upstairs. Bring cash." And we did. 1 floor up. Just went down, made an exchange, and we got 500 LiPo batteries without any issue. So that was great. The way that we got them. So we asked our supplier in China if they could source LiPos for us, and they said yes, but it might be tricky. And then I don't know what happened after that, but they showed up in Beats headphone boxes. I was not aware that that was going to happen.
Turns out you can't ship LiPos by plane.
Well, you can just on cargo. You can't ship it as like on a commercial passenger. But yeah, there's a big our LiPo boxes have warnings up the wazoo on them. All right, here's QueerCon.
Hey, I'm George. I'm a third of the QueerCon badge team. This is Evan. He's the hardware guy. I'm the software guy. Among the badge community, I'm kind of known for 2 things. One of them is a slavish devotion to Texas Instruments. And the other is getting added as a friend on Facebook by the sales reps at our Chinese suppliers, and also receiving inappropriately familiar emails about their vacation plans. So, yeah, dealing with China is a really unusual kind of experience to have, apparently especially for me. So we're a little different in some ways than some of the other badge communities. We've been doing this for about 5 years, and from the outset, our goals have been mainly surrounding community. So we don't have hackability as a major goal of our badges, in part because our group is really a social subgroup of the technical conference. So, there are some things that you can kind of do, and last year we had some, daughter board capabilities, but that really doesn't ever factor into our design nearly as much as is our goal to make people interact with each other using the badge as the vector to accomplish that. And that's really what informs everything that we do as a team. Another thing that we've done every year that we're really proud of is our first year we did 100 of these. That was 5 years ago, I think. And we didn't sell any of them. We just gave them all away. And we've started doing paid pre-reservations for them, mostly for people who book with our block in the hotel. But even though we do now do paid pre-reservations, every single year we've given more away for free than we did the previous year. And that's something that we really want to continue being able to do, is to have folks who are able to take part and get them for free. That was partly enabled this year by Starbucks sponsoring our badge, so that was great. If you happen to see anybody wandering around with a cup of coffee on their screen, that's because they're one of the sponsors. That's all they asked for. They wanted a special little icon to show up on the lights. They didn't even want anything on the board, so that was great. Our stack is built, well, really the experience is built around these really cool self-mating hermaphroditic connectors. It's an Amphenol part called a RotaConnect, and they're these surface mount parts that are technically only rated for 25 uses, but they work. And so the entire basis of it is connecting them together. There's a little game based on this really irritating but still addicting web and phone game called Alchemy, where you start with a handful of elements and you combine them with each other to create new ones. And there's 44 different ones that can be explored by all the attendees, but you only have access to the most recent one that you've unlocked. Via the QueerCon app on phones listens to Bluetooth beacons that come from the badge and hits a web service to populate what amounts to a leaderboard, even though it's collaborative rather than competitive, so there's not really any leaders. But in our suite, we've got a big screen up that shows a map of all of the elements that can be unlocked, but the ones that nobody's gotten so far are question marks. And whenever anybody gets one, they sort of start populating, and you can see the the map of how to connect them. More or less. Going back to my slavish devotion to Texas Instruments, we actually kind of also have a triple core badge. Our part is the main processor is an ARM Cortex A3. It's an RF system on a chip from Texas Instruments called a CC2640. It's actually got two Cortex A0s on it as well, one to run the radio core, and another that's like this low-power sensor controller that was too complicated for me to figure out how to use, so I don't use it at all, but it's on there. And then we also run a TI LED driver, and then we have, I think, 15 channels of multiplexing across all of these LEDs. So there's, what's 49 plus 24 is 63 RGB LEDs, and they're just dumb LEDs in a neat little 0606 form factor, bought from China for 2.8 cents each. That's actually the vendor that added me on Facebook. We've used them a couple years in a row.
They're great.
They are. They're great, and they're very cheap, but kind of strange. Kind of talking about the production thing. Last year, I don't know if you saw the bloopers, the little squid badges with the aqua-colored LED eyes. Those eyes that made it, or the LEDs that made up the eyes, we bought all of them, as far as we were able to tell. We couldn't find a single U.S. supplier that had any left after we were done, and we couldn't even find a Chinese supplier that had any left after we were done. We had to kind of cobble them together from multiple sources.
We bought Arrow, DigiKey, Mauser.
Yeah, and then that weird Chinese distributor whose logo was the Windows logo rotated 90 degrees. Yeah, I was like, well, it's worth the $60 to find out if they're actually real. So anything you want to add, Evan?
Sure. So as they mentioned, you really want to start. Sorry, this is only my second time with a microphone, and the other time was this morning, and I was hungover as fuck. Still am. So yeah, overdoing it. So yeah, whenever you think you need to start 2 months before that. So we'll start the design for next year probably on Sunday, and there it begins again. So other funny stories from this year is we had a really cool idea, and we'd been wanting to do it, and we were working really hard on it. I hadn't started designing at all in January because we're still waiting on the kind of graphics. and we suddenly decided that that's going to be a low return on investment, going to be a lot of work. People aren't going to understand it. I can't tell you what it is because we might actually end up doing it next year. So we scrapped everything in January and started over again. And this was sort of the, okay, this is just what I have sitting around in my brain. Let's just make it happen. I'd already started the schematics because I kind of saw it failing. And so we cobbled that together pretty quickly, and it works fine. Another funny to the lead time problem is one of the resistors, which is normal, like 2K resistor. We went to order them, and it was like, oh yeah, they're out of stock. Okay, what's the lead time? 52 weeks. No, 54 weeks, I'm sorry. It's like, so if we order them now, they won't be here in time for next year. Good, okay. So like sometime next year, we're going to get a little packet of some LEDs, or some resistors, and wonder where the hell that came from. But,
a couple things in terms of kind of process of developing these things. Some people touched on this, but we typically go through a handful of designs that have nothing to do visually with the final design. So we'll typically buy an evaluation board of whatever chip we've wound up deciding to use, and then essentially build a development board that can plug into it using breakaway headers and just hookup wire to validate it electrically. And then as of the last couple of years, we've also been doing orders of boards that we have no intention of actually assembling, just in order to test out different visual elements. So we actually ordered one of these with all four corners having different designs on them, just so we could sort of evaluate which ones looked good or not. There's a shop, Crypto Privacy Village uses them for all of their assembly. We use them for prototypes, called PCBWay, and they are faster than any U.S. shop that we've used. You can order.
Make Gerbers on Sunday, get them in your hands Friday morning.
Yeah.
for like $5.
Yeah.
Plus $25 shipping, but
Well, yeah.
so nice to send them in batches. But.
Yeah, but it's fantastic. They're a great tool for that. I mean, it's cheaper and faster even than using one of the batch services based in the U.S. like Osh Park or Batch PCB before them, and so on.
All right. So I guess there's a new event at DEF CON this year called Whose Slide Is It Anyway? Where you present someone else's slides and you have no idea what they are. I have sort of seen these in advance, so we'll just try to BS our way. Some people, I don't know. One of them actually designed the original Crypto and Privacy Village badge because that guy, he was very interested in doing a badge, and then we tried to get him to do last year's, and he's like, no, I'm doing Bender instead. So whatever. Boop. All right. These were the guys who suggested the BMD 300 with BLE to talk to everyone. It does BLE. It has, a nice fancy 128 by 128 color LCD that can do like 20 frames per second of video. That is pure BS. They actually were going to use the APA 5050 LEDs, but they melted in the lead-free process, and actually the WS2812Bs did not, so they had to replace that at the last minute. Slow power, has SD card, has lots of puzzles, blah, blah.
They were hand-building all the LEDs.
Oh, did they?
Because the lead-free process wouldn't work for them because it was too hot, so they got them in as fully assembled boards without the WS2812Bs on them.
Oh, right.
Hand-built within iron.
Yeah. So they have this Chip 8 emulator, which is some like retro console emulator thingy. They have a mode on here that will actually connect to a bottle of vodka, which has a LED display on it that talks BLE, and they like reverse engineered that. Has some tickle-ish scripting language on there that it supports. Boop. It was a long process. They started the day after DEF CON last year, and they were a lot more on top of their game than we were. Boop. They have some tips. I guess they make fancy charts because they actually do that for a living. They're in like management hell. And then Kickstarter, and yeah. stuff. You can read the tips. Boop. All right, that was it.
Hey. Yeah, one more thing.
So when I first sat down to do the software for this, when I got the screen working, I thought, how can I do video? And when I saw how much trouble it would be, I put it aside for a while. And then when we joined the Slack where everybody was demoing their stuff and talking, I saw an early prototype of the Bender badge with a little video player on it. And I'm like, well, shit, now I have to make it work. So I went back and finally managed to do it. But it was a real big challenge. But that was what inspired me in the end.
All right. All right, guys. Well, thank you guys very much. Thanks, badge makers. Thanks, badge buyers. Really, without you guys, honestly, what are we doing this for? If you think about it. Yeah, we got your money, and you have a badge.